All right, we're now into Math 1108 course, doing the practice test on Chapter 9, which deals with radicals and their functions. All right, let's start with number 1. Now, for something like this, as you look at the problem and you wonder, well, what do I need to do here? What is it they're asking? Well, they're asking us to add these if we can. But since the radicands are not the same, we can't add them. But we can simplify this one. And that rule was 5, the cube root of something, times the cube root of something, plus 2, the cube root of 3. Now, the background on this is we are looking for a possible perfect cube factor of 81. 81 is not a perfect cube. But if we did this, 81, now we know we can take a 3 out of that, because if we add 8 plus 1, we get a 9. And 9 is divisible by 3. So this is 27. Now 27 is a perfect cube. So we put that over here. And then what's not a perfect cube is the 3. So now these parts are the same. And we take the cube root of 27 and get 3. 5 times 3 is 15. The cube root of 3 plus 2, the cube root of 3. And now, since our radicals are the same, we can just add their coefficients, and the answer is 17, the cube root of 3. We have simplified. Now, for this one, they simply want us to simplify this, putting it in your calculator, and then round it to 2 decimal places. So when I did that, I got 4.123 and some others. So this is irrational, of course. Now I look at my third decimal place, it's a 3. So I just drop it. And my answer would be 4.12, rounded to 2 decimal places. Now, for this one, we're asked just to simplify it. And the procedure was to put 2 radical signs. And of course, this implies multiplication. And we're looking for the number part of the radicand. Is there a perfect square factor? Well, again, if we did 27, a 2 and a 7 added together is 9. 9 is divisible by 3, so we can take a 3 out of here. And you may know this already. But there, 9 now is a perfect square. And then the part that's not is the 3. Now, when we look at the variable to pick out the perfect square, we say, what even power of x? So that would be x to the 4th. And then there's an x left over. So now under the first radical sign, we have all perfect squares, and then whatever isn't. So this then becomes 3x squared, the square root of 3x. And that's the protocol. Now for example 4, they're asking us to solve this equation that includes a radical. So the technique we said was to isolate the radical, which we did, or it's this way already, but then to remove the radical sign, whatever the index number is here, we raise that to that power. Now if we do this side, we must do this side also. So then this just becomes the radicand. 4 minus t equals 25. And if we want our t to be positive, we move it over to this side, and that becomes a positive t. Move the 25 over to this side, becomes a negative 25, and 4 gives me a negative 21. So there's our answer. Now, we said pretty generally you have to check this to see if in fact that will work. So let's put it in there. 4 minus a minus 21, and we're taking the square root of that. Does that equal 5? Well, this becomes a positive, and that's 25, and the square root of 25 is 5. So that's a good answer. T equals negative 21. Now, as we look at this example, I set it up here a little bit. What does this equal? Well, remember, right now, every value is over 1. And there's a 1 up there as well. But this is a negative exponent. And to make this exponent positive, we need to move this base down to the denominator, where this becomes this to the 3/2 power. But remember, we said the denominator of our fraction is the index number of our radical. And then this is the exponent to which it's raised. So I've converted this, which is a negative exponent, to something with a positive exponent, and then changed it from its fractional exponential form into its radical form. Alright, so let's simplify that a little bit more. Now, what is the square root of 9? The square root of 9 is 3. And what is the square root of x to the 4th? X to the 2nd. Now this is raised to the 3rd. Okay, so now it's rather easy. Our answer is going to be 1 over. Give you a moment to do this. Here we're using the power rule. 3 to the 3rd power is 27. And then we multiply our exponents, x to the 6th. And we have simplified that through a series of steps. For this one, we're only asked to select which is the graph that represents this radical. The strategy then would be to plot some points here. So how do we find where it's going to anchor to our graph? Well, we take the radicand, negative x plus 2 is greater or equal to 0. So when we solve this, we can just transpose the negative x to this side, it becomes a positive x. And then this is 2. So just this simple step gives you where this radical will be anchored to our graph. And it's going to be here at 2. Now again, when we went over this lesson in our earlier lessons there, the flipped classroom video of this, there are some other things to note. For instance, we said in general, just as a little review, y equals the square root of x. Well, when x is positive, here x is negative. When it's positive, it's going to have this general shape. And then we said if it was x plus 2, when x is positive, it shifted this over to this negative 2, actually. So it was opposite sign. But here you have to be careful because the x itself is negative. So again, just using this technique, finding where you're going to anchor it, that is your best method for getting this type of graphing correct. Okay. Notice the way this is written as opposed to something like this. Now, in this case, this is a real number. This one is not a real number. So when we take the square root of 27, again, we're having a negative. We can think of that as a negative 1 out here. And then we're going to divide the square root of 27 into 2 parts, where we look for a perfect square factor, the largest perfect square factor 27, which we did already, which we know is 9. And the square root of 9 is 3, so this will become a negative 3, the square root of 3. And again, this is not a real number here, when the negative is under the radical. We had said that if our index numbers were even, 2, 4, 6, these are not real numbers. But if under the radical sign we had a 3, 5, 7, that is an odd index number, then it's okay to have a negative under the radical sign. Now, for number 8, we're asked to rationalize the denominator. Well, as we look at this, this is not a perfect square or a perfect fourth. So this, in this form, is irrational. So we want to make it rational, and the process is called rationalizing, and in this case, the denominator. So I took the liberty of saying, what is 27? Well, it's 3 times 3 times 3. So we want to rationalize that. Well, what do we have to multiply it by to make this a perfect fourth power? What number do I put here? Well, just another 3. So now this becomes 3 to the 4th, which is 81, which is a perfect fourth power. But since I multiply the denominator by this, I have to also multiply the numerator by this. Now, since our index numbers are the same, we can just multiply our radicands, and we're going to get 4 to the fourth root of 12. Let me say it that way. Now, our denominator is going to be the fourth root of 81 now, which is a perfect fourth, which is 3. So I've simplified by rationalizing the denominator. In this form, it's irrational. Now it's rational. For question 9, we're asked to simplify or evaluate this. Remember, the square root is an operational symbol like plus or minus or divide. And what two numbers gave us this? Well, we know 5 times 5 is 25, so it's going to be 5, and we have 4 decimal places. So to square this, to get that, this then is the square root of it, 0.05. Because if you squared this, you would get that. Now, you could also put that in your calculator, and it'll give you this too. Okay, let's go on here. They give us some easier ones towards the end here. We have 12 questions. So the half power of anything, we say when we convert it from its fractional exponential form, we take a radical sign. The denominator of our fractional exponent becomes the index number. The base becomes the radicand. And then the numerator of our exponential fraction is the exponent of our radicand. So this is just the square root of 100, which is 10. Now, if they had something like this, negative 100 to the 1/2 power, that would be not a real number, because that would be then the square root of a negative 100. And an even number index, you can't have a negative under the radical and have it be a real number. All right, little review. All right, this one's sort of in two parts. If we multiply the 6 by 30, they want us to get the square root of 180. But they want you really to simplify this. So notice what we could do here. We could simplify this by saying the square root of 5 times the square root of 6 times the square root of 6. And do you see here we have the square root of 36 and the square root of 5, using a technique we had into simplifying radicals. So this is 6, the square root of 5. So if you did the 180 in this fashion, you would get the square root of 36 times the square root of 5. And that's the second part of this. That's below, but we already have the answer here. Again, if you have any questions on these things, bring it in the lab. Ask your teacher, the tutors. They're very knowledgeable about these things. All right, this is our last answer, or question. And as we look at this, we're asked to simplify. Well, notice here, the radical and the radicals are the same. So we would just add the numerical coefficients. And this would be a 1 that we don't write. The cube root of y. And then this is what's left over. Minus 5, the cube root of 3. Alright, this finishes our practice test. Again, there were only 12 questions, ran about 20 minutes. And, you can make up your own practice test. Bring in any questions you have challenges on, and we could help you. All right.